Hey guys, Mr. Bowman here. Today's learning objective is in green and we're learning about a new type of model. And our learning objective is we are learning to describe the assumptions and features of a uniform distribution. So I'm just going to underline uniform distribution because this is sometimes called a rectangular distribution. And that name is a bit more useful because it gives us some information about the shape of our model. So let's quickly draw an example. So that's our y-axis, which relates to the probability of an event, and that's our x-axis that describes whatever variable we're measuring. The distribution typically looks like a rectangle, hence rectangular distribution. Based on its shape, just like uniform distribution, there's a couple of assumptions that must be met for this model to be appropriate, and all of them are based on the physical features of our graph. So let's write a little notes list on this side of the graph. So we've got our assumptions. The first one is events must be equally likely. Equally likely to occur. And what that means is that really represents the rectangular nature of us. At every single point on our graph, each outcome is as equally or as likely as the other. Without that assumption, you don't have a normal distribution model. Okay, the next assumption is there are upper and lower limits, or another way to say it, there is a defined minimum and maximum. And we can see by our graph, there is a defined maximum and a defined minimum. They don't, unlike a normal distribution curve, they don't carry on forever. There is a fixed point. There are no values beyond those points. And the last one, similar to normal distribution, we're still looking at continuous models. So your data must be continuous in nature for this model to occur. So just underline that. Those are our assumptions, and those come from the model itself. Okay, carrying on from that, we're now going to chat about the parameters of our shape. We always refer the minimum value as A. So A is always the minimum, and B is always the maximum. And the other thing that we're always interested in is the height of that shape, or the height of a rectangle. So let's have a think about this rectangle in particular. So if we were calculating the area of a rectangle, we would be going area is equal to base times height. And we're thinking of probabilities at the moment. That rectangle represents every possible outcome, which means the probability of that is going to be equal to 1. And that means the area of our rectangle is 1. So that means 1 is equal to base times height. The next thing we want to think about is, just a reminder, we're still trying to figure out the height here. The base of our shape, if you have a look at our rectangle down the bottom, B minus A would be the base of that shape. So that there is the base. So it's the maximum minus the minimum. That's the base of our rectangle, which means our height is equal to 1 divided by B minus A. And we've used the area of a rectangle and our probability knowledge to determine that. So I'm just going to write that down there. Height is equal to 1 divided by B minus A. And finally, the last feature that I want us to discuss, I'll just change pen colors for this one, we'll use the white pen this time, is how do you calculate the mean? So the mean is typically the middle average, or the middle point. And in our case, the mean, nice and easy to figure out, it's A plus B divided by 2. So we're finding the middle or the average of those 2 points. So